In this lesson, we're going to look at limits. A limit is the value that a function approaches as the input or independent variable approaches some value. The limit can approach the independent variable can approach some value from the left or from the right. If we are looking at the limit as it approaches from the left, the notation that's used is a negative superscript on the value that x is approaching. If it's approaching from the right, we put a plus superscript on the value that x is approaching. The x can also approach infinity, and the limit of a constant is always the constant regardless of what x is going to approach or the independent variable approaches. You can directly evaluate a limit by substituting in the value that the independent variable approaches directly into the function. There are some cases where you may be able to, there may be discontinuity that exists, but it can be removed by factoring the polynomial in most cases. Once you factor the polynomial, you may be able to cancel a common factor in the numerator and the denominator, removing the discontinuity, and then you can use direct substitution at that point. If there exists a jump or a kink, you want to pay attention to whether the limit, you're trying to evaluate the limit as x approaches from the left or from the right. In the figure, you can see that the limit is going to have a different value if x is approaching from the left as it would if the limit is approaching from the right. And whenever you want to observe what happens to the value of the function as x approaches positive or negative infinity. So take a look at the function. If you have a continuous function and x is approaching infinity, then you need to only look at the term that has the highest degree, and that will determine what the value of the limit will be as x approaches infinity. And if you are unable to eliminate the discontinuity, then the limit may not exist. All right, in this example, we can just use direct substitution to evaluate this limit as x approaches 3. If I replace the x with 3, negative 3 plus 2 is negative 1. And then the cubed root of negative 1 is just negative 1. And then negative 1 is positive 1. And here we cannot immediately use direct substitution, because if we plug in 2 for the x, then we'll get 0 in the denominator, which will cause the which will make it undefined. So we need to first factor the numerator to see if we can remove that discontinuity. So when we factor the numerator, we get x and x in the front. The two numbers that we can multiply to get 2 and then add to get 3 are going to be 2 and 1. The constant is positive, so that tells us that both signs for the binomials will be the same. The linear term is negative, so that tells us that they're both negative. And now we can cancel the x minus 2's, removing the discontinuity. Now we can use direct substitution. When we plug in the 2 for the x, we get 2 minus 1, or 1. And then here we have a break in the function. We have one function for all the values of x less than -3, and then for all the values of the function, all the values of x equal to or greater than -3, we have a different function. For the values less than -3, for the x's less than -3, to the left of -3 we have a parabola. To the right of -3 and including -3 we have a line. All right, so we have two different functions on both sides of -3, so there's a break. And in the limit, we want to evaluate the limit as x approaches -3 from the left, and we know we want to evaluate it from the left as x approaches -3 from the left because there's a negative superscript. So x, it approaches from the left for all the values of x that are less than -3. So we want to use the top function, the -x² minus 2x. Use direct substitution at that point, plug in the -3 into the top function. -9 plus 6 is -3. And for this one, we have a continuous function. So we need to only look at the term that has the highest degree to determine what the function is doing as when we evaluate the limit as x approaches infinity. So that first term, that quadratic term, is the term that has the highest degree. So if x approaches infinity, and we're squaring that value of x, as x gets bigger and bigger and bigger, the square of that value, that quantity, is going to continue to get bigger and bigger also. So as x approaches infinity, the entire function is going to continue to approach infinity. So the limit of that continuous function as x approaches infinity is going to also approach infinity. It's just going to keep getting bigger and bigger. And in this example, we want to go ahead and factor the denominator because, let's see, if we were to plug in 4 for the x, we would get 16 minus 36 plus 20, which would give us 0 in the denominator. So we can't immediately use direct substitution because that value of 4 would give us 0 in the denominator. So we have to factor the denominator to see if we can remove the discontinuity. X and x in the front, the two numbers that we can multiply to get 20 and add to get 9 would be 5 and 4. The constant term is positive, so that tells us that the sign of both binomials is the same. And the linear term tells us what both signs are. They're both negative. And now we can we can cancel the x minus 5 factors, but we still have x minus 4 in the denominator. And if we use direct substitution at this point, the denominator is still going to be 0. So the limit does not exist.